My name is Robert Brankman. My topic was neural processors, also known as NPUs. I selected NPUs because I find the inner workings of computers very interesting. Given that there's a lot of talk about how expensive AI computing is, both from a computational standpoint and an electricity one, I wanted to learn about how the industry is working to make AI more efficient. NPUs are specialized devices that have been designed with optimizations for AI from the ground up. So a typical CPU is used for generalized computing. These have just a few cores. They tend to focus more on the capability to perform more complex operations in a linear fashion. A graphics processing unit, or GPU, introduces a high amount of parallelism thanks to having thousands of slower cores that are much simpler in design than a CPU core. NPUs are a blend of the two designs, featuring more cores than a modern CPU, but significantly less than a GPU typically. AI tasks also do not require high precision, so NPUs improve on efficiency over a GPU by performing even simpler math. Typically, this is around 8 bits based on the research that I did. The design of NPUs is also unique that the chip is organized significantly differently compared to a CPU and a GPU. Most NPUs are organized similar to neurons of a brain, hence the name neural processor. These neurons have a different layout for the memory and all the transistors used for the calculation, which results in different pathways that the tasks can run across, which vastly increases the throughput of the AI task based on the typical types of math that has to be performed. So for my website, what I did was an AI generated photo straight from Wix. This first green one here was the one that was designed by Wix as part of the template, but I really liked it. In the news, I chose 3 articles. One of them is using generative AI to drive Industry 4.0. So Industry 4.0 is all about the interconnectedness of the manufacturing industry. So one of the things using generative AI can do is try to fine-tune a maintenance plan, is one of the topics that these articles cover. Another article that I chose was the inevitability of NPU computing. And this talks about just generalized use cases for these NPUs. And then finally, I chose robot-guided 3D machine vision applications. So I work in the robotics industry, specifically the plastics industry, and one of the things that we're moving towards is having more advanced systems. A lot of what I've done in the past has been picking parts out of a bin or off of a conveyor system and then inserting them into a mold, so that way the plastic can flow around the middle part, and that's how you get things like laptop bases with all of the screw posts embedded in them. So this machine vision application is a way for AI to help the robot figure out what is the best part to pick from a bin of randomly shuffled parts. Moving down, there's a couple use cases of AI that I'm sure everyone's heard about, like these little robot dogs. the future of prosthetics might have NPUs embedded in them to make uh, things like grabbing cups easier with less chance of slipping or uh, dropping them. And then down here we have a Hyundai factory that's using a bunch of articulating robots to assemble a vehicle. So AI might be used here to help fine tune the movements, or they might do inspection with a camera with AI where they take a photo and then the photo is analyzed to make sure that nothing was missed during assembly. On my research page, we have my paper that I wrote. So I summarize that with my little introduction. And then we have the media side of things. So Intel is one of the major vendors for processing CPUs. Um, and they are obviously going into this NPU market as well. So I selected a YouTube video from Intel that they discuss what some of the use cases are and some of the challenges that goes into designing an NPU. Firuz Aflatuni, I think is how I pronounce his name. He is a electrical and systems engineering professor at the University of Pennsylvania. He has several articles and papers published on AI, one of which I found really interesting was an on-chip deep neural network for image classification. So that paper that I linked to here, what they're discussing is instead of having a traditional processor look at an image where you take the image and then you convert it into RGB data and then you analyze that, this paper talks about directly analyzing the light from the image. So analyzing the light waves on the chip directly as opposed to converting it to binary data first. And then finally, I also have a video of this bin picking process that a company that my company interacts with all the time, Keyence. This is a system that they've recently demoed to us and that we might be looking at investing in for some future projects. So I thought that was really cool, and one of the things that they talk about is how they're planning the paths of different robots based on the design of the part, based on how the part is sitting in a bin, and if they can identify if something is problematic. So if it's sitting in a problematic orientation, they can decide, oh, well, I can recover by picking it and moving it like this, and then I can actually do what I need. So I thought that was a really cool way that the industry is using these AI tasks to accomplish relatively simple goals. They would be simple for you and me, but the AI has to learn how it can accomplish the goal within the parameters of moving a robot. So what I found most interesting about NPUs was that I learned they are being integrated into modern CPUs and GPU designs. So CPUs will be able to offload AI tasks. As you've probably heard, Windows is getting embedded with AI Copilot nowadays. So those tasks can get offloaded onto that embedded NPU, making it significantly less resource intensive compared to running it and bogging the system down. GPUs can use it for things like frame generation, which would typically be a very resource intensive thing, but NVIDIA has this technology called DLSS, and they're basically taking two frames that are generated and figuring out what the difference between them is and displaying that in order to compensate for having less than the refresh rate of the monitor. I think that at some point in the near future, we're probably going to start seeing PCIe slots and devices dedicated for consumer, well, prosumer and gamers mostly, slots dedicated to NPUs that you can put in your home computer or your work computer in a PCIe slot. I think that's going to be commonplace as games and other devices start using AI more locally and less in the cloud.